So these are the steps that I consider when I'm doing a problem with proportional reasoning. I first write down the formula that seems to relate all the values that are being described. Sometimes I need to combine two formulas. You'll see this in the third examples. Then I rearrange if needed to solve for the value that I'm being asked to find. In our examples, we won't need to do this. If a value stays the same, I just enter 1 into the formula. If the value changes by a certain factor, then I enter that factor into the formula and I square root, and so forth as the formula tells me to do. Let's see how this works out. So here it says that the speed of this object is v. It's assumed to be moving in uniform circular motion. So the formula that I would be thinking about is v equals the circumference 2 pi r over the period t. And so now when I look at each of these other examples, what I want to do is in this formula think about what the new speed would be. Okay, so the new speed is going to be some factor times 2 pi r times t. I guess I should use a capital R since that's what the picture's showing. And so the 2 is not going to change, so I'm not going to worry about that. Okay, the new speed, the 2 doesn't change, the pi doesn't change. What's changing here is the r. Okay, and so in this formula, I'm going to rewrite my formula here. What's changing is this part right here, the r. The 2 and the pi and the t all stay the same. So if I were to put that 5r in, I could be very formal about this. I would put 5r instead of just r. And we could see that this, pull out the 5, factor out the 5, is 5 times the original amount. And so the new velocity, the new speed, is going to be 5 times v, 5 times the original amount. But again, really, I could have just sort of thought about this by looking at the original formula and saying, well, the 2 doesn't change, the pi doesn't change, the t doesn't change. The only thing that changes is r, and it changes by a factor of 5, so v changes by a factor of 5. All right, let's try another one here. So I'm going to write the formula down. I'm going to think about what it is that's going to change. In this case, the 2 doesn't change, the pi doesn't change, the r doesn't change. It's the t that changes. Okay, so 2 times pi times r divided by now 3t instead. And so I could pull out 1 over 3, got to keep the 3 on the bottom, times the original amount. And so my new speed would be 1/3 times the original speed. This is the new one. All right, let's do this again in more of a shortcut version with this next one. All right, so here's my original formula. Again, I'm going to pay attention to what is changing and what stays the same. 2 pi don't change. Here, the r changes and the t changes. So that means my new is going to, on the top, change by a factor of 5, and the bottom, it's going to change by a factor of 3. So the new velocity is 5 over 3 times the old velocity. All right, let's try this with another formula. So in this case, we have acceleration that's being discussed, same circular motion. So the formula that I want to write down is acceleration equals v squared over r. Okay, so this is the formula I'm going to be thinking about here. In this case, the v doesn't change, it's still just v, but r changes to 4 times r. And so my new acceleration is going to be 1 over 4, again, because the r is in the bottom, 1 over 4 times my original acceleration. Let's take a look at this one. Okay, so what changes? In this case, the v changes. Now, notice that the v is being squared in the problem. So when you change v by a factor of 3, you're actually changing it by a factor of 3 squared. All right, and so my new version is going to be 3 squared, or 9 times the original acceleration. My last example here. Okay, in this case, both of the variables are changing. The v is changing by a factor of 3, and the r is changing by a factor of 4. So everything we did in the last 2 questions, both things are going to happen. The v changing by a factor of 3 is really a 3 squared, because the formula tells me to square the velocity. So that's 9. And my r is changing by a factor of 4, but it's dividing by that number. So it divides by a number that's 4 times as big. So my new acceleration is 9/4 times my old acceleration. All right, with these questions, I don't have a formula right off the bat that involves both v and m and r, all those things. And so I kind of have to think of a formula. Now, the question is asking about force, so I'm kind of thinking F equals ma. I'll write that without the sigma. Okay, so that would bring in the m, but then the a is, that's not one of my variables. What I have, though, is v and r. So I'm going to remember that a is v squared over r, and I'm going to plug that in for a. And so I sort of have created a new formula for this particular situation, where we take the mass times v squared over r. Let's see how this works with our problems here. You write down my formula and think about what changes and what doesn't change. So in this case, the r is not changing, but the m is changing, and the v, which is squared, is changing. So when the m changes, that changes by a factor of 3. When the v changes by 2, it's got to be squared. 2 times 2 is 4. And again, the r isn't changing. So my new force is going to be 3 times 4 times my old force, or 12 times my old force. Write my original formula down here. Again, some people find that tedious to do, but I think it helps me stay organized. So in this case, the v is not changing, but the m changes by a factor of 4. The r changes by a factor of 3. So let's see what that would look like. My new force, so m changes by 4, that's on the top of the fraction. The v is not changing at all, so I can ignore that. And the r on the bottom is changing by a factor of 3. So I have 4 over 3 times my original force. My force would increase by a factor of 4/3. All right, one last one. Maybe you can pause the video and see what you would do with this. This one's got a fraction in it, so it's a little bit different. All right, so the m doesn't change. The v does change. Make sure I square that when I do it. And the r changes. It gets smaller. Okay, the r goes down by a factor of 1/3. So when you divide by something that's smaller, you're going to get an overall bigger amount. So we should sort of anticipate that as we're thinking. but let's just kind of go through the process here. New force, mass doesn't change. V changes by a factor of 2, and it's squared, so 2 times 2 is 4. And the R changes by a factor of a third. Okay, so that means there's a third, not a 3, but a third in the denominator. All right, so let's think about what that would mean. 4 divided by 1/3, we would flip the fraction, and this would be the same as taking 4 times 3, or 12 times my force.